Hello, everyone. Um, Welcome back to PMAT0028. So, on first day, in the first session, we talk about a number, and we made a recall what a fraction is. You introduced to improper fraction and proper fraction. We made a recall on a positive and a negative integer. You also were introduced to another type of another type of number we call the absolute value. That number is nothing but value, and we use or arithmetic operation to we use those to evaluate a arithmetic expression. Okay, and in order to do that, we have to use a concept we call the order of operation. Okay, so those number or those type of value can be represented by a letter. Okay, that letter we call the variable. That letter we call the variable. In the number or the value we learn, for example, decimal number, fractional number, we can consider as a constant. Okay, we can consider a constant term. Okay, and then we have variable and we have constant, and we want to combine those together. We have something new we call the algebraic expression. Okay, instead of arithmetic expression, we have algebraic expression. So the difference between arithmetic expression is that, and algebraic expression is that, in algebraic expression we have variable term which is contain x or y or z with letter. In arithmetic expression, we have only number. We have only value. It could be absolute value. It could be decimal number. It could be fraction. It could be positive, negative. It could be power number. Okay. So for the lecture today, we want to learn what algebraic expression is. We want to simplify algebraic expression by combining line term. Okay. So let's write them down. So this is covered in section 3.1 of the textbook. Okay, so algebraic expression. Okay, and how to simplify algebraic expression by combined line term. That is our goal for today, for this session today. Okay. All right. But first of all, we need to know what algebraic expression is. I already say. So intro. So algebraic expression containing constant term, okay, and variable term. Okay, variable term. Variable term is the term that has x. Okay, variable term is x and y and z is this letter. Okay, and it can be algebraic expression can contain arithmetic operation, or it can contain a parenthesis also. Okay, for example, I have something like this. I have 2x plus 3. I say this is algebraic expression. Okay, you see that I have two terms right here. The terms are separated by addition or subtraction sign. Okay, So we have a number itself. This is we call a constant term. It's valid, okay? But this one we call a variable term because it contains x. Okay? Even though it has a number 2, but because it contains x, so we call it a variable term. If we have a number itself, we call it constant term. Okay, so in this algebraic expression, we have two terms. Term is separated by arithmetic operation. What I mean over here is addition, subtraction, not multiplication. Okay, not division. If it is separate by multiplication and division, we call it factor. So if you look at this locally, you see that we have two factors. The first factor is 2, and the second factor is x, because over here it is separate by multiplication sign. So there's a multiplication sign right here, but we don't use it. You don't see it. It says the dot sign right here. But usually we never write the dot sign right here. Okay, we just write 2x instead of writing 2 times. Okay, so we have two terms, and the first term we have two factors. Okay, so now you can see the difference between term and factor. Term is separated by addition and subtraction. So hint, remark. Sorry. Terms separated by subtraction or addition sign. Okay. Factor separated by multiplication sign. Okay. So 2x plus 3 is algebraic expression. I can have something more complicated algebraic expression. For example, I have some over here. I have like 4x to the third power plus 2x squared minus 3 plus I over 2x. Okay. So this is also algebraic expression. Okay. And in this algebraic expression, we have 4 terms. We have 4 terms. Okay. The first term is 4x to the third power. The second term is 2x squared. Okay. The third term is -3. The fourth term is +5 over 2x. And however, we have only one constant term, which is 3 or -3 if you include the minus. But we have 3 variable terms. Because whatever you see over here, that including x, that will be variable term, and the one that not including with x will be constant term. Everybody clear on this? Okay. So that is algebraic expression. Now, on the second part of the lecture, I want to show you how to simplify algebraic expression. Okay, and in order to simplify algebraic expression, we need to know which terms are similar to each other. Okay, second part, simplify algebraic expression. Or sometimes we call that the combining line term. Maybe some of you already heard before, combining line term. Line term, it means what? It means similar term. That's what it means. But how similar? All right, we need to take a look deeply into that. Okay, line, it means similar. But how similar? All right. When we mean similar, when we mean line term, we mean that variable term, okay, must have the same denomination. Variable term must have the same denomination. Okay. If it's a constant term, it will be very easy, right? Because constant term is just number, we just add them together. For example, 3 plus 2, 4 plus 5, blah blah blah. But if it is a term that contains x, then it must have the same denomination for you to combine. If it's not the same denomination, then you cannot combine. For example, over here I have, for example, 1. I have 2x plus 3x. I say that these two terms, because we have the two terms over here, right? Because it's separate by addition sign, so we have two terms here. And I say that these two terms here are like terms. They are similar terms because they have the same denomination. What is denomination? Which is whatever after the number. So I put a red line over here. I underline red right here. Because it's 2x plus 3x. X is the denomination. It means that we can combine it. So our answer should be a 5x here, using the same denomination. Okay, the same denomination. I can give you another example. Example 2. For example, I have something like this. I have 3x squared plus 7x squared minus 4. I have a question for you. You know, I want to know. I want you to ask me how many terms in this algebraic expression. Or maybe some of you know that this is 3 terms, right? We have the first term, variable term. The second term is also variable term. Okay. And the last term is a constant term. You cannot combine constant term and variable term together. You can only combine variable term together and constant term together, not constant term and variable term together. Okay, it means what? It means that I can only combine this. And the reason I can combine it because they have the same denomination. The denomination in this case is x squared. So 3x squared plus 7x squared gives you 10x squared. But we cannot combine with 4, so I'm going to just leave 4 over there. So our answer will be 10x squared minus 4. Okay. In the third example, I'm going to give you something. I'm going to give you an algebraic expression that whose term had a different denomination. Okay, and because it's different denomination, then you cannot combine. For example, I have negative 3x to the 4 minus 2x. The denomination of the first term is x to the 4 powers, and the denomination of the second term is I. You cannot combine it. Some of you like give me negative 5x to the 5th power. It doesn't work that way. Okay, so we can combine. We can combine. We cannot simplify it. Okay, so the first example and the second example, I can simplify. All right, or something like this. I have like 4y squared plus 2z. Totally different one. It's not similar anymore. So can combine. Okay. So from these 3 examples here, I can make a conclusion. And my conclusion is that we can't combine banana to apple. It means that I cannot add 2 banana to 3 apple. We don't have something called banana. Okay, since we don't have something called banana. All right, so remember, we can only combine banana together, or we can combine apple together. We cannot combine banana to apple. All right, 2x plus 3x is 5x. 6z plus 5z is 11z. 6z plus 2x, we cannot do it. Okay, because 6z is 6 apple, 2x is 2 banana. We can't combine. Okay, everybody clear? Good. Now, let's take a look at another example here. I just want to remind you one more thing. Maybe I forgot. All the number in front of variable term, for example, number 2, number 3 here, we call the coefficient. Okay, so number 3 here we call also coefficient. 7 is coefficient. Okay, but the number itself, it is constant term. All right. So that basically is how you simplify algebraic expression. You know, the thing is that it's not always simple like that. You know, if we have an algebraic expression like 2x plus 3x, so everybody know it turned out to be 5x. Okay, but you know, sometimes they add parentheses into the algebraic expression and they want you to simplify it, or sometimes they add a power number into that, or sometimes they add absolute value into that. So they can add anything into your algebraic expression and they want you to simplify it. And in order to do so, in order for you to be able to simplify any algebraic expression, you need to know 2 properties. And maybe some of you already heard this property also. Okay. The first property we want you to learn is we call it distributive property, which is what it means that if we have a coefficient and or a variable, for example, variable a, okay, and I want to distribute, I want to multiply by b plus c, then I can follow it, so it becomes ab plus ac. Okay, ab plus b. That's distributed following, everybody knows. Okay, and the second property I want you to know, we call it a commutative property. Commutative property. And this property, it can be in multiplication form or can be in addition form. If it in addition form, we have a plus b, then equal to b plus a. And if it is in multiplication form, we have a times b equal to b times a. Now, totally makes sense, because just think about it. We have a 2x plus 3x. It is the same as 3x plus 2x. Okay, because both of them turn out to be 5x. Right? It's the same. For example, I can give you an example really, because you have a 2x plus 3x is the same as 3x plus 2x. Both of them turn out to be 5x. Okay, and it works the same for the multiplication property, commutative property in multiplication form. Okay, this property you will be using a lot when you evaluate algebraic expression, or when you want to simplify algebraic expression. Okay, let me give you another example on simplifying algebraic expression. Something more complicated. Okay, something that you have to use a distributive property. Okay. So example 1 over here, example 2. Simplify. Okay, the following algebraic expression, something like this. What if I have a -2 times x minus 5 plus 4 times 2x plus 2. Wow, look at that. We have parentheses, right? It means what? It means that we should apply distributive property. And after we apply distributive property, what we have? So I'm going to put equal right here. So I distribute it into the parentheses. -2 times x become -2x. -2 times -5 become +10. Negative times negative is positive. We already learned positive and negative integer. And you do the same thing where you make sure you have to distribute the addition sign in front of the number 4 right here. So positive 4 times 2 is positive 8x. A positive 4 times 2 is positive 8. Okay. But the question is, are we done? Or we have to do something more? Are we done? Well, look at this. I have two constant terms, which is we can combine, right? We can combine them. And we have two variable terms that have the same denominator. It means it is similar to each other. And because it's similar to each other, I can combine them. -2x plus 8x gives you 6x. And -2 plus 8 equals 6. Everybody know how to add and subtract positive negative integer. It's in math development 1. Okay, 10 plus 8, 18. Can we stop right now, or we have to keep going? Look at that. We have the first term, the second term, the constant term. We're not allowed to combine constant terms to variables. So we're going to stop right here. That is the final answer, because these two terms, they are not similar. One term with variable, the other term, it just value a number. Okay, so that is the example that relating to distributive property. Let's see what else we're supposed to do for this lecture. I'm gonna give you something more, something crazier, you know, something more interesting, so that you can see that similar. When I mean similar term, it could be anything. It could be very complicated, but it's still similar to each other. For example, to simplify, I have 4xyz minus 8xyz plus 3x squared y plus 4xy squared. Oh, how many terms here? We have 4 terms, right? We have 4 terms. You know, I don't want you to look at each term locally, because if you look at each term locally, you can find how many factors in that term. But right now, I want to look at it as term. Okay. I don't want you to find fact. Okay. So let's see, we have any term similar to each other, any term that contain the same denomination. All right, let me look at that. Okay, this is coefficient, right? We already say this is another coefficient here. And after the coefficient, we have the denomination. We have x, y, z. Over here, we also have x, y, z. So it is the same denomination. It means I can combine it. I mean, I can combine these two, which is give you a negative 4xyz, right? Because 4 minus 8 is negative. Now, let's take a look at these two terms right here, and we check that if it had the same denomination or the similar term or not, okay? Okay, so on the third term, we have 3x squared y. But on the fourth term, we have 4xy squared. Do you think that is similar or is different? Can we combine this? Xy squared and x squared y. It's different, right? Because look at that. It is x squared over here. Is x, and it is y. This is y squared. So this is not the same. It's not similar. It's not like term. So we can combine. Okay, so our final is that negative 4xyz plus 3x squared y plus 4xy squared. Okay. What if I have 3x squared y plus 4yx squared? What if I have something like that? What if I have something like that? Let make it example number 4. Okay. So example number 3, that's all we have. Okay, we can combine this. But what if I have 3x squared y plus 4yx squared? My question for you, they are similar terms. They are like terms. The answer is it looks like it does not, right? It look like it does. It look like it's not similar term at all. It look like it doesn't look like each other at all. But be careful if we apply commutative property. X squared y is the same as yx squared. Since x squared y is the same as yx squared, right? We just commute. They are just commutative of each other. Okay, they're not different. The position is changed, but they are the same. Okay, because between them the multiplication sign. So this is commutative property. Okay, they are the same, and because they are the same, so I can combine. Okay, so 3x squared y plus 4yx squared is basically, it is 7x squared y. Okay, or 7yx squared. It's the same meaning. Okay, you can write down 7x squared y or 7yx squared as the final conclusion. Okay, so I want you to remember that when you combine like term, when you simplify algebraic expression, you have, first of all, you need to find, you need to see if it is similar term. You make your own decision is similar term. Okay, you can use a commutative property to check if it is similar term or not. Okay, you gotta make you can use the remark, you know, I put over here, yeah, to see if apple and banana are not. If it's banana and banana together, we can add, or if it's apple and apple together, we can add. Okay, and you have to look at carefully. Okay, don't ever jump into conclusion right away. Okay, this is xy squared and this is yx squared, and you say this different, and it's wrong, right? Because basically it's the same. If we apply, if we look at that by using the commutative property, then it's basically the same. Okay, because they're basically the same, then we can combine, we can simplify. All right. On the last part of our lecture today, okay, I want you to learn how to evaluate algebraic expression. Evaluate algebraic expression. So in the first section, section 2.5, we learn how to evaluate arithmetic expression. And when you evaluate arithmetic expression, you apply order of operation. Right? You need to know which one go first. Okay, and you just deal with a constant term. You deal with number. It could be any type of number, but only number. There's no variable yet. But when you evaluate algebraic expression, okay, that because it's algebraic expression, it contain, that's when it contain variable x. And when I mean evaluation of algebraic expression, what you do is just basically you replace the variable with a number. You replace variable with a number. For example, something like this. Let me see. I can have anything over here or not. Yeah. Interesting. I want you to evaluate. Sorry. Evaluate. X minus 5y squared. Okay, for x equal 2 and y equal 4. X minus 5y squared, it is algebraic expression, and there are two terms. However, they are not the same. They're not similar terms. But it doesn't matter because we are doing evaluation right now. So we don't care if it is a similar term or not. We're not doing simplification. Okay, so how are we going to evaluate it? How are we going to evaluate algebraic expression? Basically, we just replace the x and y variable with the value given. So we here x equal 2. So I'm going to replace x with 2. So I'm going to have 2, right? Minus 5. Then I replace y with 1. So I'm going to have 1 squared. Okay, so my final answer will be what? If I apply order operation, remember order operation we learned last time, we have to do parentheses first, right? The power number. Okay, PEMDAS rule. So I'm gonna have 2 minus 5. 1 square is 1 exponential. Right? PEMDAS, parentheses exponential. Okay. So 1 square is 1. Then 5 times 1 multiplication go before subtraction. So it becomes 2 minus 5 times 1 is 5. Then 2 minus 5 is -3 as the final answer. Okay, so all the tests you had to show me to work like that. Okay, and every time you do other operation, you have to put the equal sign. Okay, I already reminded of you when we did other operation last time. Okay, so -3 here is the final answer for this problem. Okay. Let me see. I can give you something else. Something harder. My algebraic expression, it could be in fractional form too. Example 2. It could be in fractional form. That's fine as long as it's algebraic. Then it's okay. How about like this? What if I have like 5y minus x over y for x equal 1 and y equal 2. I want to evaluate this. All right, so this is algebraic expression. You're going to contain variable term. Okay, there's no constant term, the old variable. Okay, the number over here is not constant term because they attach. And this number is attaching to the y, so this is coefficient. Okay, so all you have to do is you just replace 5y is 2, so 5 times 2 minus 1 over 2. Okay, other operation, we're gonna do the top first. They say that the first time. Every time we have fractional form, we're gonna do the top first. You can do the bottom first, but you see that the bottom over here we have only 2. So you can do the top, and the top we have multiplication and subtraction. According to PEMDAS, we're gonna do multiplication first. So 5 times 2 is 10, minus 1 is 9 over 2 as the final answer. Because the bottom we don't have to do anything. Okay, the bottom is just a number after replacing it, just a number. Okay, good. All right. Any question? And you can send me a message through Canvas. Okay, so basically that is all for the lecture today. Okay, basically that is everything covered in section 3.1. I already say that in the on the first day, I see that section 5.5, which is about fraction and decimal number, I already to talk on the first time, the first class, the first classroom session. Okay, and section 3.1, I'm going to do that on the video, which is I'm doing right now. Okay, so I think that's all for today. If you have any concern, any question about algebraic expression, how to simplify and combine like term algebraic expression, please let me know. Send me a text, a message through Canvas, and don't forget to do your homework. Okay, the first week homework is due May 16, which is the end of this week. So I want you to, I really recommend you guys to start the homework as soon as possible and watch the video of section 3.1 about algebraic expression as soon as possible. Okay, then I'll be seeing you guys next time. Bye bye.